Again, good morning, everyone. So today we'll start with the new subtopic of this chapter. And this subtopic, so far we dealt with how magnetic field is created. Okay, due to current or due to motion of charged particle, magnetic field is created. Now, from today onwards, we deal with magnetic force. We have we have studied about electric forces, electrostatic forces. Can magnetic field also create a force? Yes, magnetic field also may result in magnetic forces. And the law related to magnetic force also is an experimental law, like many other laws, gravitation law, Coulomb's law. This also is an experimental law. So before we go into law, we'll just try and understand what kind of experiment led to the law here. And only thing new is in this particular topic is only this. So just imagine, so we have understood if a current is flowing in a conductor or a wire, it could be straight or any other shape. For simplicity, here we've taken a straight conductor. So when current flows here, it creates a magnetic field around it, and we know what the formula is. So there some experiments were conducted. So if you want to check what will happen to a charged particle when it is placed in a magnetic field, what we do, we allow some current to flow and keep a charged particle here at rest. And what was found when the charged particle is kept at rest, we don't find any force acting on it. The first thing what we understood, a charge placed near current carrying conductor, which is when placed in a magnetic field, experiences no force. So magnetic field does not work on charge at rest. Then what was tried? Okay, let's give charge some motion. So what happens if you project the charge in different direction? And what was found that when we project in different direction, even if the speed is same, different direction, the force acting was not the same. So, which indicated the force which will act, first of all, force will act on the charged particle only when it is in motion. The magnetic force acts on a charged particle, not at rest in motion. And second thing, it also depends on force direction as well as magnitude, depends on direction of motion of charged particle. So what was done here, to suppose we have this kind of experiment, well, if we continue further, trying to understand what the results of this experiment were. So let's see which direction the field will get created wherever charge is. The field right hand thumb rule, if you apply, the field will be created into the plane of paper. Okay. So now we can try different, same speed, I can project the particle in different directions. And what was found, if the particle is projected into the plane of paper or particle was projected out of the plane of paper. In both the cases, when the particle is projected into the plane of paper, since the field also into the plane of paper, angle between them will be 0, and out of the paper, angle between them will be 180. In both the cases, force was found to be 0. No force acted if the particle was projected into the plane of paper and out of the plane of the paper. So what does this indicate for this experiment? If we have to infer something from this experiment, it clearly indicates if angle between B and V is 0 or 180, force is 0. And then we tried, okay, what happens perpendicularly? Let's look at since the field is perpendicular to plane of paper, any direction we project this particle in the plane of paper, everywhere V will be perpendicular to B. So here in this particular case, when this particular case we have taken, it is projected along or parallel to the wire, which is perpendicular to direction of magnetic field. It turned towards left. A positive charge turns toward left. What does this indicate here? Okay, the force acts, but force acts not along the direction of velocity. Force acts perpendicular to direction of velocity. So 3-4 things here. What are 3-4 things we understand? And all those 3-4 things can be easily captured in form of a mathematical expression. And you see, that's why we have certain things like dot product and cross product, which makes things more concise and precise and easy to understand once we know the properties of dot and cross product. So we noticed here, yes, the force acts only on moving charge particle. And when the angle between them is 0, velocity and magnetic field is 0, 180, force is 0. And force was found to be maximum when angle was 90 degree and force was perpendicular to velocity. All this point, how do we express in a neat expression? And when projected direction current, it reflected towards wire. And this is the expression. if we write in terms of this expression, it captures the force acting in the particle for any particular direction of motion of charge particle. So once we understand this is only part which is new. So magnetic force acting on a moving charge particle is QV cross B. This itself indicates if B is 0, if charge particle is rest, magnetic force is 0. And which direction does it act? It acts in a direction perpendicular to B as well as B, and it follows cross product. So those who understand, we have done cross product few times. If we understand properties of cross product well, and if we apply it here, this is nothing new. We can understand every part easily. So again, if it is a cross product and it involves two vector quantity and result also is a vector quantity, that itself indicates it should have been a cross product. And the fact that angle 0 and 180 force was 0 indicated it cannot be dot product, has to be cross product. So what is the magnitude of force? We simply use the property of cross product. It will be QEB sine theta, which tells you the magnitude of force is maximum when sine theta is equal to 1 or theta is equal to 90 degree, or when velocity is perpendicular to magnetic field. So in this case, if field is into the plane of paper or out of the plane of paper, any direction we project in the plane of paper velocity, it is perpendicular to magnetic field. What does theta indicate? Theta indicates angle between two vectors involved, V into B, V and B, tail to tail. That's what we need to keep in mind. So many cases what we do, either we directly, if both are given in IJK form, I can use the cross product property. If they're not given IJK form, we can find magnitude separately and direction separately. And many times we do that. So magnetic force will be 0 if direction of motion is along the direction of field or opposite. This is natural inference from property of cross product. Direction of force will be perpendicular to velocity as well as magnetic field. And we can also say direction of force will be perpendicular to the plane containing velocity and magnetic field. So if, okay, Alan, yes?
Sir, why don't we take the field in the direction of force, sir, in the first place?
Why do we take field in the direction of force? I didn't say that.
Why don't we take, sir?
Huh?
Why don't we take that and make it simpler, right?
I'm not getting your question. Whether this something, see, what I've written nothing new. I've just mentioned one thing. I've just stated the law. And this is law. So this law is a cross product. We have not stated anything new. I'm just saying whether I'm just explaining which is already should be known, which is property of the cross product. And
You're saying why don't we take the magnetic field in such a way that it'll be along the direction of force?
Okay. See, force is outcome of particular choice. This is something I think, just think of your question yourself. I think you'll get your answer. Can I, is there a choice between direction of force? Force is an outcome of velocity and B. That's what the law says. So can I choose a direction of force? No, I want force in particular direction. Absolutely not. So force is an outcome of V and B. Whichever direction we take, V and B are there. If we have particular, this something, S is a result of these two, and it always follows this law. So can I decide, no, I want to have force which is parallel to B. Can I have this one? If force is a cross product, can we have a force which is having component along B? Impossible, if the law is valid. So this is simply law statement. I think just think of your question, what your question is. Yes, anybody has any other question?
Yes, sir. Sir, we can't explain why a charge at rest will not experience magnetic force.
Tell me, try and answer yourself. How did we, what was the experiment conducted? Any single law. Based on what? What is the proof of gravitation law? What is the proof of?
Yes, sir, it's experimental.
Experimental. So what did I say initially? How do we think that what does this first thing say? When we pass a current here, we keep a charge particle experiencing no force. What does it tell you?
Yes.
Is the conclusion difficult to draw?
And it's dependent on velocity also.
So basically what we do, we conduct numerous experiments and see, can I express the result of all experiments in terms of a law? This is the law which never fails. That's what I think I repeated a number of times, and all of you must understand. What is a law? Law is something with no experiment can be conducted which is in conflict with the law. So can we conduct an experiment where we find, oh, magnetic force is acting along B? Impossible. That's what the law says. Till date, nobody could conduct an experiment which contradicts the law. Okay. So that's why I think this is one you need to understand what does law mean. Law means something it has never been experimentally disproven. And that is something I think once you understand, the question on law itself will not come. Question should come on interpretation of law, not on what the law is. Okay. So, okay, for same velocity and magnetic field, okay, what will happen? So, if this is positively charged particle, same thing. If we keep everything same, if we make this Q can be positive or negative. What will happen if we change the sign of Q? If we change the sign, naturally the direction of force also will change. So, whatever direction of force was acting on a charged particle, if everything else we keep same, if we change the charge to negative charge, direction of force will become opposite. So similar way, if there's a positive charge particle, if you project a positive charge particle, it experiences force towards the left. If we replace with a negative charge particle, we give same velocity. It will experience force towards right. This also, I'm convinced that does not require an explanation. That's a simple interpretation of this equation. We just keep repeating those points, but this is something once we understand what this equation means, this is a natural outcome. We are just stating what is the natural inference of an equation, which by now we should understand is the relationship between vector quantities. It's a cross product. It follows the principle of cross product. Nothing new. Okay. Yes, Alan.
Sir, in case of a wire carrying current, the force will always be towards the current, right?
See, okay. For the moment, you forget this. This is experimental setup, which has led to this law. You focus your mind on understanding the law. Is there any difficulty in interpreting this? What you can do, once you have the law, you can do this. If using this law, what observation they would have had during the experimental, which led to this law. Okay. So what would happen? This is one, this particular figure indicates one particular set of experimental. This gives you only one experimental setup. So based on this law, can you also anticipate or predict what would have happened? Suppose you take a different case here. So try and I'll answer this question. Then suppose I had this current I here, and rather than projecting towards, what happens if I project a positive Q charge towards the wire? What will happen? So this is the direction of velocity, which is direction of B. This is direction of B. All you need to do, which direction the force will act?
Downwards.
So basically, I don't do anything, but I'm not thinking what will happen current. This is a law given. Yeah, it will be V cross B. What is V cross B? But how do I find V cross B? V cross B, right hand thumb rule. So I imagine, I think this is my finger should curl from V to B. B is what? I have to keep a pen which is pointing into the plane of paper. From V to B, if I turn my fingers, my thumb will point downwards. So this would, if I project like this, if it is a positive charge, since force will act downwards, if actual experiment was conducted, which I'm sure in many cases was conducted, this particle will then bend downwards. When direction of velocity changes, will the force direction remain same? If it bends downward, means what? Will it keep moving in the same direction? No, direction of velocity changes. As the direction of velocity changes, will the force acting in the same direction?
No, sir.
It will change. That's what we need to understand here. Okay, so direction is given by right hand thumb rule. And let's try and understand right hand thumb rule. And this particular case, again, I have chosen a particular coordinate system which is consistent with right hand thumb rule. If I want to choose Z direction in vertically upward direction, if I take this as X direction, Y direction has to be into this like this. Then only if I curl my finger from X to Y, my thumb will point along Z direction. I cannot write this as X and this is Y. So I hope this point is clear. Every time when we choose coordinate system, it should always follow right hand screw rule or right hand thumb rule. So I have taken this view, and which direction the field is along negative Z direction. So this three-dimensional representation I can capture in this figure also. This figure and this figure are same. What does this cross sign indicate here? This indicates presence of magnetic field, which is perpendicular to plane of paper. It is going into the plane of paper. So I hope all of you start understanding this this kind of figure. This indicates uniform magnetic field into the plane of paper. and that's what the cross indicate. And I could have written, this is, if I have to write in terms of vector form, I would write magnetic field is equal to some B into minus K cap. Let's take time understanding magnetic field is one thing is clear. How do we interpret? If magnetic field is perpendicular to plane of paper, then force will always lie in the plane of paper. Which again, all of you, if you're not able to comprehend, think it over. This does not require a fresh explanation. This comes basically from property of cross product. If magnetic field is into the paper or perpendicular to plane of paper, force has to lie in the plane of paper. And when it lies in the plane of paper, let's look at this. Only two directions possible. Mark the direction of forces. Let's take this case. What is this case? This case indicates direction of magnetic field. It indicates charge is positive, indicates direction of velocity. In terms of words, I can mention, if a particle is projected along x-axis, which direction will the force act? So can you all mark direction of forces? First of all, force will lie in the plane of paper and it will be perpendicular. See, any line I draw in the plane of paper is perpendicular to B. So one condition is met, any line if I draw by the line like this, this, or this, all are perpendicular to B. Any line in the plane is perpendicular to B, but in addition to perpendicular to B, it has to be also perpendicular to B. So if I draw, so the force can either be like this or this. There are only two possibilities. There's no third possibility. As following the, now between the two, whether it is upwards or downwards, that comes out of right hand thumb rule. So all of thumb rule, you need to all practice and make sure you get a hang of right hand thumb rule. So if I keep one finger in this direction, other going into the plane of paper, if I might curl my finger, something like this, how my finger will curl in this particular case? The finger has to curl from, field is in which direction? Field is in the Z direction. So if I look from here, if I look at this figure, this is direction of velocity. And in this case, this is the direction of B. If my fingers curl, which direction my fingers point here in this figure? How would my fingers have to curl? From first vector to the second vector. First vector is B. Which direction? If I curl my finger, it is pointing in which direction?
Y, sir.
Y direction. So here also, if I see it will pointing Y direction, here also where it will point, this is how the force will be. And if you are not finding curling your fingers easy, I use not this one, I use something else. I use a notation. I always use this one. A positive charge in a dot field, force will be towards right. So in this case, I notice is a positive charge. It's not a dot field, it's a cross field. The force will act towards left. So those who understand left and right, if I'm facing this direction, this is the direction in which the force will act. And if I apply this case here also, let's take in all cases, all of you try and mark the direction of forces. Can you all do mentally? There are three cases I have drawn. All three cases, can you mark direction of forces? And if not, you practice a little more. Well, practicing marking direction of force. So can all of you think in your mind, what will the direction of force act in this particle? Let's look at one by one. On this particle, what will that first one mark? First one I marked which is direction of force. This is direction of force. I'm using dot right, but basically since the field is cross, charge is positive, force will act towards left. If this direction of velocity, left is this direction, or I can take right hand thumb. In this case, there are two possibilities. This force is towards right, this force is towards left. Which will be there? Force will act towards right or left. Since the field charge positive, field is cross, force will act towards left. This is the force in direction in which force will act. So we can take V cross B. So if I have to visualize here, what is the direction of force in this 3 dimension? I would have done something like this. What is the direction of velocity in this particular case? Direction of velocity is somewhere like this. Along. This is velocity. And this is B. So in this figure, if I had to do V cross B, how would I do V cross B? Which direction V cross B will point? If I curl my fingers from V cross B, my thumb will point towards left direction. That will be FB. So I am doing in both cases 3 ways you can do. You can do from here itself, you can do right hand thumb rule. You can convert into 3-dimensional figure also, you can do that. And third thing what you can do, you can use positive dot right, if you understand. If it is negative, it will be other way around. So what will direction of force? Can you all figure out direction of force on this? First thing, immediately what should come to mind, which is easiest, force will be along this line. either upwards or downwards. It will be perpendicular to V and the plane of paper. Can we mark which of the two is correct? That will come from right hand thumb. This is V direction. My finger should curl into the plane of paper. Which way it is coming? If my fingers are curling from V into the plane of paper perpendicular, the force direction comes which direction? First direction or second direction?
Okay, first.
First direction.
Huh?
First direction.
First direction.
First direction. Well, so if it was positive, it would have come two directions. So many of you, I think this is something of 3-4 exercises. All of you, this requires little more practice and not requires nothing much we can explain. Of course, it will act in the first direction. So all cases practice direction of forces. Okay. So I think I don't use thumb. I think I feel comfortable dot right. And if it is cross left, positive. If it is negative, first I find the charge on the positive charge and I reverse it for negative charge. Okay. So I think left, right for me, it is easy. It is any of the three methods, whichever method you feel most comfortable with, you can follow. Okay. Now let's understand what will happen as what we notice here. What else we can interpret from here? Magnetic force is always perpendicular to velocity. What happens when force is perpendicular to velocity? You need to use some properties what you learned in first year. It will not do any work. It will always be perpendicular. So whenever force is perpendicular to velocity, and velocity is always in the direction of displacement. So it implies force is perpendicular to displacement, work done is always zero, and work done is always zero, it means kinetic energy remains constant. So any particle which is moving only under the influence of magnetic forces, its kinetic energy can never change. Its kinetic energy will remain constant. So that's one thing we understand. Second thing, suppose you take here. So this particle here, I have projected like this. So it is positive charge. Which direction the force act? We have worked out in previous case also. Force will act like this. So because the force is acting like this, it will not continue. It will turn towards the direction of force. So little time later, it has moved here. From it has come here. And when it is come here, what is the direction of velocity also become like this. When the direction of velocity like this, now again the force will be perpendicular. Sometime later, again, so again it will turn which direction it is moving. It is turning along the direction of force. Sometime later, I find it has moved here, and again this becomes velocity. If this was v here, this also remains v. This also remains v. Magnitude of velocity is not changing. The force is perpendicular, keep changing its direction without changing its magnitude. The force, when acting perpendicular to velocity, the component of it only changes direction, not the magnitude. Here also, force will act in the same direction. Perpendicular direction. So if it keeps happening, what kind of path it will have?
Circular path.
Circular motion, uniform
Centripetal
circular
force.
motion. What we understand, we try to recall. Where do we get uniform circular motion? What is the property of uniform circular motion? If the force is always perpendicular to velocity, if force is and constant magnitude. If magnitude of force is same, always perpendicular to velocity, it gives rise to circular motion. So from here also, nature and trajectory of motion of charged particle projected in uniform magnetic field, and which direction? Perpendicular to direction of magnetic field. So magnetic field it is perpendicular to magnetic field. It will move in a circular path. If it is circular path, we'll apply the property of circular path. So whenever you have circular path, which are the parameters which are important in case of circular path? What is the radius? Where is the
Omega.
center? What is the, if it's circular path, it will have time period, it will have frequency. All those terms we can arrive at. So can we find out those terms? Yes, we can easily find out. Let's find out if it moves in a circular path. These are parameters given. Magnetic field is B. Q plus this is the charge, this is the mass, this is the velocity. And this is speed also, you can say. So it will keep moving in a circular path at a constant speed. How do we find radius? Magnetic force will be constant. The force is constant magnitude and perpendicular velocity produces circular motion. Radius of circular path, how do we find it? We equate the force, perpendicular force to mv squared by r. So this is when we put those values here, we find the value of radius of circular path. Radius of circular path from this equation is equal to mv by qb. So this important formula is very easy to derive also, but this is something we can memorize. This is radius of circular motion mv by qb. So suppose that when the particle is here, can I mark the center of circle, where the center of circular motion lie? So first thing what I do, I mark the direction of force, which is perpendicular to velocity, and center will lie along the direction of force. So center will lie somewhere along this line. At what distance? I mark a point which is a distance r from here. That becomes my position of center of circular motion. It will keep moving about this point as a center. I can write this expression in three forms. This is mv by qb. This term is nothing but momentum. So sometimes information is given in form of momentum. Same equation can be written as p by qb. And momentum also can be expressed in terms of kinetic energy. So when kinetic energy is given, I can write in this form 2m into k, k being the kinetic energy divided by qb. But even this also, k also sometimes can be written in form of qv. Can you think of what is this qv, what does v, qv is it? What does this v term imply here? Capital V. So many times charge particle, how do we impart kinetic energy to charge particle? So like a particular mass, if you drop an object from high point to
Potential difference.
potential difference. So what is V here? V is nothing but potential difference or charge Q when accelerated through a potential difference of V acquires a kinetic energy QV. That's the term. In place of K, it is QV. Charge into, and we sometimes use the word accelerating potential. Why we use accelerating potential? It increases. We are saying it is moving from higher potential energy to lower potential energy. Moving from where? From higher PE to lower PE. It is losing potential energy and is gaining kinetic energy. So these are 3-4 forms, same equation can be written. Can we find out time period? Shravani, can you tell me how do you find time period now?
Sir, 2 pi r by v.
So perfect. I'm so very quick. Oh, time period will be what? Time period is distance by speed, which is 2 pi r by v. What is v equal, r equal to? R is equal to mv by qb. So 2 pi mv by qbv. Vv gets cancelled. So time period is 2 pi m by qb. That's the time period. And what is surprisingly what we find here, it is independent of velocity. So what does it mean? If I have one charge particle q, mass is m, velocity is v, and I project another charge particle. Another charge particle is something what? What we notice here? This is q, m, and 2v. What is saying both will have same time period? Does it make sense why these two particles can have same time period? If velocity is 2v, what will happen?
And the force will adjust accordingly.
Radius will become double. So first particle goes into this particle, and second thing which has twice as much velocity will trace a path like this. So radius is double. So what will happen? Both particle again complete the circle at the same time. So if velocity increases, everything else remaining same, radius of circular motion also increases in the same proportion. Hence the time period comes independent of velocity. This also important property which is used in cyclotron. So if this is a time period, inverse of the time period is the frequency. So what we need to memorize, I think this is an important point very quickly. What we understood here, magnetic force is always perpendicular to velocity. Hence, it doesn't do any work. Kinetic energy remains constant. And since force is perpendicular to velocity, and if field is constant, force magnitude will be constant, always perpendicular, it will give rise to circular motion. And when we equate per centripetal force equal to mv square by r, we get the radius is equal to mv by qb, which can be written in 4 different forms. The same thing can be, so once we remember, we can easily convert into this form, or this form. So whenever a question is given in form of accelerating potential, I can, in place of k, I can substitute qb. So one, yes, of course it get corrected. And then we calculate time period. So we haven't done anything new. Only thing new what we have done is FB is equal to QVB, and we have just interpreted the significance of cross product. Right. Okay, let's look at some simple question based on this. And they are pretty simple. There's nothing new. Only thing what we have done, we just defined a new rule, and it's a simple cross product application. This product is very simple. What comes to your mind? What we have to calculate here? I have to calculate force. Which kind of force? Magnetic force. And in this particular case, do I even have to worry about the direction? No, I have to only worry about magnitude. So what is magnitude of magnetic force? B is equal to QV cross B, or
QVP sin theta.
QV sin theta. Okay, so this is pretty simple. Fired with the speed and so, and 60 degrees. So are we clear about what the theta is? So this is fired at 60 degree with the x-axis. So if I have to represent it, have to mentally, if I have to get a mental picture, this angle is 60 degree. This is how the velocity is given. And which direction is the magnetic field? There's a uniform magnetic field of 0.1 Tesla applied along y-axis. So this is the direction of magnetic field is. So both are placed tail to tail. So this angle gives me value of theta, which is 30 degree, theta being 30 degree. And it's a very simple substitution. I can find out. So in this case, can you figure out which direction will the force act?
Into the plane, sir.
So basically what I notice here, field and velocity, both are lying in the plane of paper. The force has to be perpendicular to plane of paper, either in or out.
Right,
So I've used right hand thumb rule. This becomes a little easier. My finger should curl from first vector to the second vector. This is how my finger should curl. From first vector is B. It's B cross B, not B cross B. If my fingers curl in this direction and my thumb will point towards me, so force will be, which direction? Force will be out of the plane of paper. If charge is positive. If charge is negative, what I can do? I can first calculate force for the positive charge, and then for negative charge, I will reverse the direction. Grishma?
Sir?
So far, is any problem anywhere?
No, sir.
Are you okay with finding direction of cross product?
Yes, sir.
Okay, and any problem, I think again, either in the study session or you practice a little more. And those who have problem, again, we'll try some more examples so that we understand it well. With little practice, I think we can do it very quickly. That should our aim be sin theta. So other way of thinking would be direction of force. Those who are not okay, can we do in terms of cross product also? Yes. What I could have done, which direction the force will act? The force will act along the direction of cross product. So I could have written V also in terms of vector notation. V can be written as what? Here this angle is theta, V cos plus 60 I cap plus sin 60 j cap into B into j cap. So what I noted, this will not produce any force. Force is only which direction the force will act? Force will act along I cap cross j cap direction. I cross j cap is which direction? K cap. So even this also, sometimes it is possible to convert this question into form of unit vectors. We could have done this fashion also. Nishita?
Yes, sir.
Have you understood this manner also?
Yes, sir.
This okay, so we can do this way, we can do cross product. So we need to be good with finding directions quickly. Should not every time, should not be having a doubt. So we need to practice enough number of times so that we feel confident that we can find direction without making mistake quickly. Let's do this question. What is this other term also we use for doubly ionized helium atom? What is the term? Something we call. What is that we call?
Alpha particle.
Alpha particle. This is nothing but alpha particle. Double ionized tells right angle to magnetic field. This is pretty simple question. I hope all of you can solve within a minute. So can you solve this question and get an answer quickly? So this is a typical example of particle moving velocity. It is moving in a plane perpendicular to magnetic field. Simply it is based on R is equal to mv by qb. I am not using other form here, but this is given, velocity is given. So this is pretty simple. So R of, if you have to alpha particle can be written as and same thing if I write for proton, sorry, alpha particle mass is 4 mp. mp means mass of proton, and this is mp into v. In case of proton, charge is only 1 electron. So this is fairly easy. Suppose okay, Srishant. Okay. Okay, let's all of you try and solve this question. So what we need to find? Time taken to traverse a 90-degree arc. Some of you have an answer? What is the time it will take for traverse 90 degree? You can write in terms of omega and all, but pretty simple. It will be equal to t by 4. And what is the formula for t? 2 pi m by qb. Well, let's put those values. So that will be 1/4. And then we'll do and try and understand a little more also. 2 pi. Which particle? Proton. So there's nothing actually. The formula is okay. This is not problem. I think all of you can easily do. Let's try and understand few more things on this. B is given 100 millitesla. Okay, so you can evaluate this. But let's say I just extend the question a little further. What I am saying here, it is projected from origin. Along which direction? Along x-axis. Okay, and B is along minus B naught k cap into the plane of paper. Can you tell me that in terms of radius, what will be its coordinate? What will be the position of particle at time t is equal to t by 4? Does this question make some sense? Once this information given, can we calculate what will be the coordinate of particle at time t is equal to t by 4?
R root 2 comma R root 2.
R root 2 comma R root 2?
R comma R.
R comma R.
Wow.
So
R
basically,
comma
are we able to visualize what will happen here? So first we need to visualize which direction it will move into. So when I draw this figure, this is clear. The force will first, what I need to figure out. Okay, I have drawn this figure, and after drawing this figure, I need to figure out the center will lie. See, it will, if it is projected along x-axis, if field is along kx minus k cap, the force will be either plus y or minus y. So which direction does it lie? It is a dot right, cross left. Force will act towards left on the positive charge. The force will act in this direction. Hence, this is the center. So what will happen if I just let's visualize? Let me mark its position at different value of t. At t by 4, it will be here. Where will be at t by 2? At t by 2, it will reach this point. At 3t by 4, it will be here. And again, t, it will come back to the same point. So can I mark its coordinate at time t by 4? Once I figured this out, I can easily mark. This coordinate will be equal to r. What will the coordinate at t by 2? 0, 2r. and I can mark. So sometimes the question may come, either book has not given any question, but we can calculate this also. But suppose I ask you, find what is position of particle at t by 6. Can you find position of particle at t by 6? Khyati, can you tell me how do you find position of particle at time t is equal to t by 6? Khyati? Or Kaushik?
Yes, sir.
Can you tell me what will be the coordinates at time t is equal to capital T by 6? What does capital T indicate here?
Time period.
Time period. So just now we for t by 4 and all you written. I hope you have you followed this all what I have written here, Kaushik?
Yes, sir.
So similar way, can we find out where the particle would be at time t is equal to t by 6? Can you visualize in the graph figure where would this particle be? How do you define its position at t by 6? See, how did you figure this out? Are you able to figure out t by 4 it will come here?
Yes, sir.
How did you figure out why it will come at t by 4? Because total in time t, it is traversing an angular displacement of 360. So 1/4 the time it will have an angular displacement of 90 degree.
90.
T by 6, how much angular displacement it will have?
It's 60.
60. Well, so from here, it will move by angle of 60 degree. So once I mark where the particle would be, it will be at a point which makes an angular position of 60 degree. Once I figured out 60 degree and this is R, can I find this X coordinate easily?
Yes, sir.
And Y coordinate also?
Yes.
And so have you understood, is it a difficult thing to answer?
No, sir.
No. So we can find, so any such term t by 8, t by 6, we can find position. Okay, so that's the easy part. That is basically understanding property of circle. It is going to move around a circle, and in time t, it traverses an angle of 360. Any multiple of t, any fraction of t, we can find its position. So that we should be able to do that. Okay. Let's try this question. So a couple of minutes for all of you to try and get an answer. And this is an easy question to solve. Shreya, you solve, and as soon as you solve, you tell me what is your answer. So this time, this question, Shreya, Kevin, and at least Shreya, Kevin, and one more person. Who let's see who out of among the three who gets the answer first. All of three, I want an answer. One more says, and Samhita. Samhita, are you there? So give me an answer as soon as you're done. Please find an answer and tell me. Shreya, can you solve this question?
Sir,
Are you clear how to solve or not?
sir, I'm reading the question.
Reading the question, by now you should have finished the question.
No, I
Okay.
had some connectivity issue. I just
Okay,
went
no
out and
problem.
then-
Leave it then. Okay. I'll talk. Anish, can you solve this question?
Yes, sir.
Do you have an answer already or not yet? Anish, do you have, can tell me how would you solve? But before you put pen to paper, tell me how are you going to solve this question? It's a very simple question. Tell me how would you solve it?
Here. Sure.
What it is based on? Radius?
Yeah, radius is equal to, I mean, it's directly proportional to mass.
the way, see, if that's something what we know, radius is equal to mv by qb. That is what we should remember. But v is the velocity. And we can write in different forms. But here, this is something is accelerated through potential difference. What is given? It is in terms of energy. So not in this form, I need to use the form which has kinetic energy. What is the form if I convert into P and I can
Sir, is it
convert into
option 3?
2m into kinetic energy divided by QB. And what is kinetic energy mentioned? What is kinetic energy equal to?
So the velocity is same, right, sir, anyway?
Huh?
The velocity is same, right, sir?
Yes. What I'm just, so it's actually very easy question. Whether this is something, I'm just doing it even if it is not same, if these things were given differently also. Point I'm making here, this is something all a similar formula. First, you need to see what information given in the question and which one I should use. And in this case, whenever accelerating potential is given, I can use this condition. And is that a new formula? This is not much of a new formula. So what we notice here have same charge, Q1 and Q is not changing. Same potential difference, same B. So what is this thing which is changing? Only mass. Radius is proportional to square root of mass. It was such a simple question. Shreya, have you understood?
Yes, sir.
Nothing much. Have you understood what we need to pick at? And will the velocity be same? Now coming to second part. Somebody said velocity will be same. Who said velocity is same?
No, I mean, sorry, kinetic energy is same.
So what we need to look at, what is given as same, being accelerated through same potential difference. Since the question relates to potential difference, I need to use the expression which contains potential difference. Okay, so pretty simple thing, and I don't think should be any difficulty in finding that. Samita?
Yes, sir.
What happened between you not responding?
Sir, I have told the option 3, but
You are no problem at all. No? You're fair. Good.
Yes.
As long as you're following anything, no issue at all. Okay. Okay, sorry. I think this part I will do. Okay. Let's do what happens previous case where the magnetic field exists in entire space. Let's see that one. So whether it makes sense. Suppose the question is given like this. Do we understand the meaning of the sentence here? If magnetic field exists in a narrow region, and what does this indicate? Negative is that the direction is into along minus k cap direction. So if it is x and y, direction of field is into the plane of paper. And it exists only from what region to what region? It exists only from, do we understand this expression here?
Yes, sir.
It is not infinite. It only exists in certain part. So if you have to visualize something like this, it's something like this. Or we have drawn this one, something like this. So it is only up to a distance d, and beyond that, magnetic field is not there. So it is left hand side of this region also no magnetic field, right hand side also no magnetic field. So if a magnetic field exists in a narrow region, what will happen? How would our questions or method of solving will change? Let's understand. So in this case, again, I am taking something similar, so don't worry about the sign. Again, QMB, it is projected along x-axis. If it is cross field, force will act towards left. Had the magnetic field been existing in the entire space, this particle would have continued having a circular motion. So what will happen as is projected from here, until it is moving in a magnetic field, it is experiencing a centripetal force because of magnetic field. Moment it comes to this point, what will happen after this point? Will it keep having circular motion?
Tangentially.
It will have tangential motion. So whenever field is narrow and something like this, if particle is projected magnetism shown as velocity perpendicular, if d was greater than r, if this field was greater than r, suppose the field existed up to this region. If the d was greater than r, what would happen in that case?
It will be tangential to the top point.
Then it would have continued whole circular motion,
Yeah.
and come here, and from here it would have gone back. So what is necessary condition? How much is the minimum width of magnetic field we need for it to come back to the same medium? The depth D has to be more than R. But if D is not more than R, what will happen? It will escape to the other side of magnetic field, right? So if D is greater than R, particle will follow a semicircular path and its direction of motion will deviate by 180 degrees. Is it difficult to interpret the sentence? I hope all of you understood. What will happen with D is less than R? In that case, it will not be able to complete its semicircular motion. It will, as soon as it will have a tangential path. Okay, so can we calculate in terms of, can we calculate this angle theta? This is, you understand, this is angle of deviation. Can someone define what is angle of deviation mean?
Angle between the original path and the path at final.
The angle of deviation, basically, I will say something like this. This angle between these two. Angle by which the velocity changes. So here the velocity is like this. Here the velocity on x-axis. If I continue here, this is the angle of deviation. So angle of deviation is tangent at this point and this point. Angle of deviation is, because since the velocity is along the tangent and this particular direction. Okay. So angle of deviation is equal to angle between tangents, which can also be said it is equal to angle between normals. So angle of deviation is equal to angle between tangents is equal to angle between normal. This is the angle of deviation. This angle of deviation, this is the angle of deviation.
You should always take the smaller angle, sir.
Angle of deviation, no. Angle of deviation can be more than 180 also. Suppose the particle goes here, but this is the, suppose something was moving like this. This is my initial velocity. And after some time, I find this was moving towards north. If the particle starts moving along northwest direction, what is the angle of deviation? So this is, I will take V1 and V2. How is V2 here? This is V2. And what is the angle between them? Yes, of course, I'll take a lesser of the two, but in this case, angle of deviation is 135 degrees. So angle of deviation is an angle between two velocity vectors. So what is D greater than R? Let's come back to this one. So let's see what can we easily find this expression now. What are we coming to? So this is theta. You understand? Can we calculate theta in terms of R radius? R and theta. Is theta related to R and D? If I drop a perpendicular, this is D here. Is R, D and theta related?
Yes, sir.
Yes, they are related. And so it's not a formula kind of thing. So there is meaningful tangentially, angle of deviation is theta. So what is D equal to? R sine theta. What is R equal to? We know the formula of R, mb by qb into sine theta. So whenever these terms are given, can we calculate angle of deviation? I can use this equation to find angle of deviation. Not difficult at all.
Sir,
Okay.
it's tan, right?
This, which is
No
R?
sign.
R is this, no?
Oh, okay.
Sorry, my mistake. I think R, this R, and this is R. Okay, understand this. Okay, now,
Yes, sir.
are you clear? It's R sine theta. So I drop a perpendicular from here. I hope this angle of deviation you understood. Angle of deviation is equal to angle between tangents, and angle between tangents are same as angle between normal. So if this angle of deviation is theta, it is the angle subtended at the center by the normal. And this angle is theta, this is R, and this is D. And no need to memorize the formula. It's very simple. R sine theta is equal to D. From this, I can find angle of deviation if values are given. So sometimes the question may come, what has to be D for theta to be 30 degree? What has to value of D? So if D is equal to R by 2, it will deviate by 30 degree. As simple as that. If D is equal to, if this D is equal to half the radius, it will deviate by 30 degree. So this is simple. What else may come? Other thing what may ask is, see, when it comes from here, it started with y is equal to 0. What is the extent of deviation when it comes out of the magnetic field? Can we also calculate y coordinate where it comes out of the magnetic field?
R minus R cos.
R minus. So is this a formula which you need to remember or memorize? Once you get a hang of this figure, I think sometime you write this formula. In my opinion, this is not a formula which you need to memorize at all. You memorize R is equal to mv by qb. That's the only thing which you need to remember. So this is how the motion will take place in case of field which is not infinite, a narrow uniform magnetic field. Grishma? Shachi? Are you people there in the class or not? Karthikeyan?
Yes, sir.
So far, are you clear?
Yes, sir.
Is this clear? What has been minimum value of d for it to complete semicircular motion?
Yes, sir. It should be R.
So basically, what will happen? Can you tell Karthikeyan when if d is slightly less than r? Then what will happen? And if d is slightly more than r?
So if D is slightly less than R, then it won't complete the semicircle.
Okay, then what kind of motion it will have? What will the angle of deviation if d is slightly less than r? How would it define its path?
It will be it'll go along the y-axis.
No, it will move parallel to the boundary.
The y-axis.
No, it will move parallel to boundary. If d is slightly greater than r,
then it will complete a semicircle.
if d is slightly less than r, if d is slightly less than r, what kind of motion it will have? Sorry, I have not finished the question. If d is slightly less than r, is something like this. And how it will have? It will keep moving a straight path. And if d is slightly greater than r, it will have circular path. If d is slightly less than r, theta will be equal to what?
90 degree.
90 degree. So I hope this part is easy, but by very simple mathematics, nothing you need to memorize kind of thing. Okay. I think this part I will do tomorrow. Okay, we'll start. It will take a little more time. But just let's quickly look at it. So previous cases, how it entered. Now here also there's a magnetic field. I hope all of you understand what does this expression mean. This magnetic, where does it exist, this magnetic field? Only in the right half. Left half there's no magnetic field, right half there's a magnetic field. Now this it extend indefinitely into infinite distance in the along x-axis, and this is how the magnetic field is crossed. But unlike previous case, the charged particle enters at angle theta. So just see that what kind of motion it will have here. Are this figure? All are you following this figure here? What does this orange color line indicate?
The tangent at that point.
And also this is something it will, as soon as it enters magnetic field, it will traverse a circular path. And it will keep moving and until it comes to this point. Here the magnetic field ends. From here it will take a tangential path. Here also again, so this was my, if I have to indicate, this was my v1 velocity and this is my v2 velocity. What is angle of deviation? v1 I extend here. This is v1 velocity. This was the initial direction of motion and this becomes my final direction of motion. So between the two, when they place tail to tail, this is angle of deviation delta. And what is angle theta here? Theta is angle the velocity makes with the surface, with the boundary of magnetic field. Previous case we had taken theta is 90. If we take some other angle theta here, if this angle is theta, this will be 90 minus theta and this also becomes theta. And this becomes theta, this angle also becomes theta. And this also angle becomes theta. So can you tell me what is the angle of deviation here? Can we easily work out what is the angle of deviation?
90 plus theta.
Pi minus 2 theta.
Angle of deviation is pi minus 2 theta or 2 theta? I'm just asking.
So it's
2 theta.
Just see that. Is that a difficult question? See, first of all, have you understood what is this one, this figure? Shamni, have you understood this figure? Shamni?
Yes, sir.
So you see, this is the velocity. So here, where would the center lie? Center will be, force will act perpendicular to velocity. So from this point, I have drawn a perpendicular and a distance r. So center will lie not on the y-axis like before, because velocity was earlier along x-axis. Center was on the perpendicular y-axis. Now velocity is like this. This where I mark the center. It will move like this. It will finish this one, and there could be some questions based on geometry of this figure. Once we understand geometry of this figure, these questions related to this kind of questions also, these are not formula kind of question. This also we can easily solve, which I will take up tomorrow. So we'll revise what we have done today, and tomorrow we'll continue from here. And if we have followed what we have done today, I